Assalamualaikum and good day, AB to respected teacher, Dr. Qadri and my fellow friend. Today we are going to learn about equation, function and graph. Now we are going to introduce ourselves. First, my name is Muhammad Imtiaz bin Abdul Jabbar.
My name is Wanur Aufa binti Wan Roslan. My metric number is 1212933.
My name is Muhammad Syamil bin Muhammad Ismail. My metric number is 1212950.
I'm Mashtah Munirah binti Muhammad Fakhzal 1212958.
For physical and chemical quantities, we usually link to this equation y equal to ax plus b. Y and x are the variable that can take different value, which a and b are the constant which fixed number and cannot be changed. Why the constant? Because we know in graph the equation of the straight line is y equal to mx plus c, where the m is gradient always same at the all point on the straight line. So a representative of the m, so it's constant. Beside that, b representative of the c, which is intercept of y axis in the straight line equation. In graph, one straight line only have one point that intercept y-axis, so b always constant. Coefficient of x is the constants before the x. For example, y equal to 5t power of 3 at t. So in this equation, 5 is the coefficient t power of 3 and 1 is the coefficient of t. Function which we usually denote fx pronounced as f of x. It refers to relationship between quantities. Y equal to fx. Y is equal to an expression made up of x. Next, a function takes a quantity that can be either variable or number and applies operation to it which produce new quantity. The notation is not fixed to the fx. It can be vary. For example, fx, gx, hx, or triangle x. We can also have function made up of variable other than x like fz, gz, and h theta. For the graph, we use it to see clearly the trend and patterns that are present regarding the experiment. Each experiment will have control variable that we can change, observed variable which we measure, and all other quantities we try and keep constant. We're plot the control variable along x-axis and observe variable along y-axis as shown in this slide. For the straight line, we usually use y equal to mx plus c. Y is observed variable, m is the gradient of the graph, and also describe how steep the line is. To find gradient, we need to draw triangle on the straight line. Look for the s1, x2, and y1, y2. Then we use the formula m equal to y2 minus y1 divided by x2 minus x1 to find the gradient. Next, s is the control variable and c is the y-intercept, where the graph pass through y-axis. To find c, we imply y-intercept happen when x is equal to 0. On this example of the graph, when x increases from 0 to 5, y is also increased from 5 to 15. We use the formula to find the gradient and we get m is equal to 2. When the y-intercept or c in this graph is 5. That is why the equation for this graph is y equal to 2x plus 5.
I'm gonna present about application of function and also equation. Okay. First, equation. Let's say you are given a situation. Car travels from city 1 to city 2 in 2 hours with distance of 400 km and you are asked to calculate the speed of the car. Okay, we all know that speed is equal to this distance over time. Okay, to make it simple, I will write it as s equal to d over t. Okay, next, just substitute the equation and we will get s equal to 400 divided by 2 equal to 200 km per hour. Next, for function initially developed better navigation system. For example, engineers use function for building skyscrapers and bridge. Function also used in robotics, which are used to determine how the robotics parts will work.
Okay, for the first question, calculate the pressure in ATM exerted by 2.10 mole of nitric acid in a 8-liter container at 75 degrees Celsius. So from this question, we get that the number of mole, which is 2.10, the volume equal to 8 liter, and temperature we get 348.15 Kelvin because we converted the Celsius to Kelvin. Alright, for this question, we use the formula PV equal to nRT to solve this question. To find the pressure, so just substitute the value of N and constant R, which is 0.08206, and the value of T over 8 liter. So the final answer, we get that the pressure is 7.50 atm. Okay, let's move on to the next question. Cyclopropane is converted to propene in the gas phase with a rate constant of 7.6 times 10 to the power of negative 4 per second at 500 degrees Celsius. If the initial concentration of cyclopropane is 0.25 molar, what is the concentration after 7.7 minutes? Based on the question, unit of the rate constant is second to the power of negative 1, which is first order reaction. So we need to use the integrated rate law formula, ln A naught over A equal to KT. So just substitute the A naught, which is the initial concentration, just substitute the value and substitute the value of rate constant times with 7.7 times 60, because we need to convert the minutes to the seconds. So the final concentration is 0.176 molar. Okay, next question. 25 cubic centimeter hydrochloric acid, 1 molar, and 25 cubic centimeter sodium hydroxide aqueous solution, 1 molar. Both are mixed in a calorimeter. The temperature of the solution is observed and changed from 30 degrees Celsius to 38.7 degrees Celsius. So the question asks us to determine the enthalpy of neutralization for the reaction. So in order to calculate the enthalpy, we need to know the value of Q and N. So how? First, in order to know the value of N, we need to write the balance equation for the reaction above and then calculate the number of mole of acid and base used. In this reaction, the number of mole is same, which is 0.025 mole. So we just use the value. Then how we find the value of Q? We use the formula MC delta T. So for M, which is the mass of the substance, just substitute the total mass of the acid and base and times with specific heat capacity of water, which is 4.184, times with delta T, which is 8.7. Alright, so the value of Q we get 1.8044 kilojoule. And then we can calculate the enthalpy of neutralization. Just divide the value of Q and N. So we get the final answer, which is negative 72.1752 kilojoule per mole.
For the first question, the graph shows the temperature of a substance being heated up. Find the gradient and explain the gradient of the graph. For this question, you need to draw the graph. Firstly, you must make a table. This table is to find the value of y, because in the question you already given the value of x, which is negative 2 until 4. So you need to use the value of y. You need to use the value of x and insert it in the formula, which is y equal to x squared minus 2x plus 2, and you can get the value of y. After you get the value of y, you can plot the graph. That's all. For the second question, draw the graph of the function y equal to x squared minus 2x plus 2 for the value of x from negative 2 until 4 by using a scale of 2 cm to 1 unit on the x-axis and 1 centimeter to 1 unit on the y-axis. So the formula of the gradient is y2 minus y1 over x2 minus x1. You can, from the graph, you can get the value of y2, y1, x2 and x1. So the value is 60 for y2 and 30 for y1, 20 for x2 and 0 for x1. From the value, you just can insert it inside the formula and calculate. And then you get the answer 1.5 Celsius per second. The gradient of the graph represents the changes of temperature with respect to time, which is the increasing rate of increase of temperature, that is an increase of 1.5 Celsius for every second. That's all.